Welcome again, everyone. One of the first things to do when building an application is choosing the right physical components that will collect and process the data for us. In the last few videos, we looked at a few different sensors and how to choose the right one for our use case. In this video, let's dive into how to choose the right edge device for our projects. When choosing an edge device for your application, there are several important factors you'll need to consider. Unlike centralized systems, edge computing pushes processing closer to data sources, drastically reducing latency and significantly improving real-time decision-making. This makes thinking about compute power extremely important. More powerful processors are generally needed for more complex algorithms. However, powerful processors can increase costs and energy consumption. So, choosing the right processor or microcontroller is important. An example of this is computer vision algorithms, like object detection, image segmentation, and video analysis algorithms. These are super popular and have tons of real-world applications, but generally require more compute. This is changing fast, though, as new algorithms which have high precision but low compute requirements are coming up fast. Next things to consider are memory and storage. More of these let your device handle larger models and more data. More memory allows for smoother operation when handling multiple tasks or larger data sets. But remember, accessing this memory might be slower than you'd expect in some lower-cost devices. Also, as before, it's important to strike a balance, as higher memory might increase costs and limit device compactness. Sensors integrated within the device can directly influence what applications you can support. They can streamline your product design, as well as considerably quicken your device assembly time during production stage. For instance, a device for fall detection or Alzheimer's freezing of gate or fog application with a built-in accelerometer would not only be super easy to build, but also highly practical due to its small size and weight. Another consideration when deciding on an edge device is the number and type of pins. We discussed them in detail in a previous video. The number and type of pins decides how many additional sensors or other external devices you can connect. If your project is complex and needs multiple external components, make sure that your edge device has sufficient pins. Power requirements is also an important criterion. If your device needs to operate in a remote area without constant power supply, optimizing for low power consumption is key. Another thing to note is that the external power supply numbers should match the power numbers of the edge device. In a similar vein, the edge device's current supply to input-output pins should match the sensors and external components' current requirements for the application to work smoothly and without errors. Size of the device matters too, as smaller devices work better in tighter spaces. For instance, if the size of the smartwatch or the smart glasses was too big or they were too heavy, there wouldn't be many takers for them. Now, would they? Finally, let's also discuss cost. Cost is something that your customer will always consider when assessing your product and its usefulness. Proper cost planning is important, especially if your project involves deploying hundreds of devices. This might seem straightforward, but finding a device that fits your budget, your technical and physical space constraints, and meets quality standards can be challenging, especially when deploying multiple units in field applications. And that is all for this video. I hope this overview helps you understand how to select an edge device tailored to your application's particular needs. In the next few videos, we will take a look at a few popular edge devices that you can use in your application. See you there.